Welcome to XNS Services Relayer Video Guides. This will be a multi-episode series going over the very beginnings of what you need to get started with a relayer, all the way to powerful and complete deployments. We'll begin this episode, episode 0, covering the prerequisites of a relayer, starting with the hardware and networking. Joining us in this episode, we have our first Italian partner. We have Alessandro. How are you doing today?
I'm doing fine, Henry. Thank you.
So in this episode, we're going to be kind of introducing our relayer docs, which will be a home that people certainly want to find information on. And kind of starting in this video, we're going to assume that you maybe have some idea of what a relayer is, that you have some idea of what XNet Services is. But if you don't know either, you're certainly in the right place. So xns.tech, this is the main website for XNet Services, is that right?
Yeah.
So from here, hopefully this website kind of looks familiar. This is definitely where you want to start out. And our ecosystem, you head over to resources. And while there are a lot of very good resources on this page, we have all sorts of articles and blog posts. We have our S3 app setups. Under Learn, we even have the SCP University, which is a good place to kind of learn more. But documentation is where we have kind of our written docs. So this is the landing page. And what we're going to be mainly looking at today is the relayer setup and integration page. Relayers themselves, obviously they do a lot of uploading. They ingest data from the kind of client side. They prepare it, do the encryption and erasure coding before uploading it to the network. So it should probably be no surprise that they do have some requirements when it comes to the CPU and networking considerations. You can run a kind of quote-unquote minimum spec relayer. This looks something like 8 to 16 gigs of RAM, depending on your operating system of choice. We do support both Linux and Windows. And just kind of a non-obsolete mid-range processor. So here we refer to a Passmark score of over 10,000. If you open up Passmark, if you kind of follow that link, this looks like kind of a, let's see, yeah, like an 8th gen i5 or i7, I guess kind of a low power 10th gen i5, that kind of thing. So just something that's reasonably modern, reasonably current, and could handle, yeah, lots of kind of encryption and erasure coding at the same time. That would definitely help you get the most out of it. But we'll talk about a more ideal setup in a little bit. So since relayers do lots of uploading and downloading, networking is certainly a consideration. Relayers are happiest with fast internet lines. Fiber is ideal. But even asymmetrical kind of DOCSIS or coax-based lines can work, depending on your intended use case. For fairly small-scale use, something like 30 or 50 megabit per second can work, but this will be, kind of a limiting factor for the relayer. So fiber-based internet lines tend to offer much more symmetrical upload and download, and are capable of enabling much more powerful use. So it would take about a 12-core modern CPU and about 32 gigs of RAM to be able to saturate a 1 gigabit symmetrical connection. For higher networking speeds, then the upper bound for a relayer can be quite high, can continue to scale up in performance as long as it can provide the resources. So there are some disk considerations as well. So in a relayer, there are kind of mainly two different types of space. There is a smaller kind of meta file or metadata portion, and that's really affected by being able to have a fast hard drive, something like SSD. Particularly NVMe is ideal, and then a larger file cache. In your experience, Alessandro, so this is where the data being ingested by the relayer, this is where it kind of sits as it's prepared to be uploaded to the network. Is that right?
Yeah, it can be put on a regular hard drive. It works well. During my experience in the beta testings, the relayer I used, I had it saved on a NVMe drive. The only problem I had is I was running the relayer on a Windows 10 computer, so the problem there was the operating system. I did some minor testings on a Linux computer, and back there I had the main stuff on 2 SSDs, the cache on regular Exos drives. I noticed it was kind of a little bit faster than on my NVMe computer, to be honest. But I think that was mostly because of the operating system was much better than.
Yeah, so you make a good point that with for optimal performance, and certainly with kind of workstation or server level hardware, we definitely recommend a Linux-based server distribution, this is fairly typical. And part of the reason I think why someone might want to consider going with a hard drive for cache is that we generally recommend that the amount of space you allocate for cache should be as large as the largest single data set that you might upload at a single time. So this could be in the terabytes, or maybe even tens of terabytes if you are really working at scale here. As always, you should be following along in our docs even as we cover steps in this video guide. This will ensure you do not miss any important steps, as we have the most current version of our information in our written docs. If you're feeling good and have everything so far under control, continue on to part 1, where we set up a relayer for the first time.